Alright, so when do we use each type of equation if we're going to write the equation from a word problem? Remember, we use y equals mx plus b if we have the slope, which sounds like a rate, or how much per something, or a number we're adding over and over and over again, and a starting amount, how much we had at the beginning of the problem. That would be our y-intercept. We use point slope if we have that rate, how much we have per something or every something. And then if we have a point, not at the starting, later on, a specific value later on, like in 100 miles or in 2 hours. So not at the beginning. And then thirdly, we use standard form if we have two things adding up to be a total. Alright, so today we're going to practice writing word problems again. We're going to practice writing word problems in systems. So we're going to have to write two of these word problems, two of these equations per problem. So I'm going to go through a number of examples, and if the video gets too long, we'll stop and start a new video. But here's our first one. Your club sells cookies and cookie dough to raise money. Cookies cost $15 per box, and the dough costs $12 per tub. The club sells 53 items and makes $759. How much of each item did they sell? So our variables are how much of each item. So let's make X the number of cookies and Y be the number of cookie dough. I'll say CD for cookie dough. So this is really boxes and this is really tubs. You could also do it that way. Alright, now here's the hard part. We need to write two equations that connect X and Y together, cookies and cookie doughs together. So we're not just looking for a slope, we might be looking for two slopes, or we might be looking for two totals. So when we read this, we can get $15 per box, $12 per tub. So those are information about cookies and cookie dough. And they sell 53 items total and $759. We have totals here. We have one total, that's the number of items, how many things. And we have one total, that's how many dollars. So to make our equations here, we're going to lump items with items with items, so boxes and tubs and total. And we're going to lump money with money with money, dollars with dollars with dollars. So the dollars with dollars with dollars is the easiest because cookies cost $15 per box. So $15 per box of cookies, so per X. Plus $12 per tub of cookie dough, so 12Y, equals dollars. Common units go together. Money with money with money. So the other total is 53 items total. Now this is a little harder for people at first until they get the hang of it because there's no other numbers. What numbers do we put? And the answer is we don't put numbers because X by itself stands for the number of boxes of cookie dough, that's the items, and Y by itself stands for the number of tubs of cookie dough. And so that is boxes plus tubs equals 53 items. Items with items with items. So that's our system. And then we would have to solve it. How many boxes of each did the club sell? So now you revert back into I can do substitution or I can do elimination. Personally, I like elimination. I think it's faster. So I'm going to make my X's have the same number in front. So I'm going to multiply the top equation by negative 15. So that would get negative 15x minus 15y equals, rut-row while I reach for a calculator here, 53 times negative 15 is negative 795. And then I'll combine that with the other equation, and my x's will eliminate. I will get negative 3y equals negative 36. Remember, that was a negative there. Divide by negative 3, so y equals 12. So that means 12 tubs of cookie dough. Since we're in the land of word problems, let's label our units on our answers. And so then I can carry this back to either one of the original problems. I'm definitely going to choose the top one because there's a lot less math there. And I'm going to plug in my 12. So x plus 12 equals 53. If I subtract 12, I'll get 41 for x. So that means 41 boxes of cookies. So my number of items, 41 boxes of cookies, 12 tubs of cookie dough. There's an example using two standard form equations. Let's try another example. Some students want to order shirts with the school logo. One company charges $9.65 per shirt plus a setup fee of $43. Another company charges $8.40 per shirt plus a $58 fee. For what number of shirts would the cost be the same? Alrighty, so what are the two things we don't know? Number of shirts and the cost. So let's make x be the number of shirts we sell and y be the total cost. So dollars. Alright, so now we need, do we know the totals? No, that's the question. So we won't be able to use two things adding up to be a total. Do we know a slope and a starting point? Yeah. One company charges $9.65 per shirt. That sounds a lot like a slope. And a setup fee. Well, that's how much we would start with. So $43. So one equation is going to be total cost equals $9.65 for every shirt plus 43. And then we're comparing that with another company that charges $8.40 per shirt. So there's our other slope. And a setup fee of $58. So it costs more to get started, but it's cheaper per shirt. For what number of shirts would the cost be the same? Now, since this one is a letter by itself and a letter by itself, when I come to the solving phase of my problem, I would use substitution method. If y is by itself and it's equal to $9.65 x plus 43, then I should take the y out of the other equation and replace it with 965x plus 43. I end up with x's on both sides of my equal sign that I have to combine. I think I will start with subtracting $8.40 x, so I don't have negative money. So I'll have $1.25x plus 43 equals 58. Then I'll subtract 43. This is the easy part, right? gives me 15. And I'll divide by the 1.25. So x is 12. And that's all I have to do to answer this problem. For what number of shirts would the cost be the same? X's number of shirts, so that would be 12 shirts. If I plug 12 in, I am going to find out that price that would be the same for both companies. It did not ask me, but if I plugged it in, I would get that. Alright, I think that's a long enough video for now, so I'm going to stop the video. If you would like another example with more standard forms and more slope-intercept forms, I will have that in another video for you.